and we're now starting chapter 5, and we're going to look at decimals. Now, we're going to find that decimals are related to fractions. Let me get my pen working here. There we go. Okay, so a decimal is going to be defined by a decimal point. Everything to the left of it will be whole numbers. And everything to the right will be fractions. But what we're going to do is we're going to use the fractions to be powers of 10. So if we looked at our place values that we had for whole numbers, what we found was, let me pull over here. So what we were able to find is that our whole numbers, we had the ones place, the tens place, the hundreds place, the thousands, and so on. If we use our rules of exponents, this was 10 to the 0, because anything to the 0 power is 1. This was 10 to the first. This was 10 to the second. And this would be 10 to the third. So when we wrote a number in expanded form, say we had 324, we wrote this as 300 plus 20 plus 4. A subtlety to the place value was we had 3 times 10 to the second plus 2 times 10 to the first plus 4 times 10 to the 0. And so this was in our place values. And the thing to note is that the powers increase to the left and decrease to the right. And so we exploit that to make the decimal point. So if we start looking at the decimal point, if this is 10 to the 0, and this was 10 to the first, and this was 10 to the second for the place value, then in continuing downwards, this would have to be 10 to the negative first. And our power rules say that anything to a negative power is the same as 1 over that power. This is a rule we're going to learn in our collection of rules, that a negative exponent has meanings. It becomes divisions. And this means this is the fraction 1/10. And so the next place over is 10 to the negative 2, or 1 over 10 squared, or 100th. And so each place in the decimal becomes a fraction of powers of 10. And so decimals let us write very specific fractions as long as they contain powers of 10. Now we'll learn to convert this between other fractions, but for right now, this becomes our driving force in how we set things up. So if we read this, if we have a decimal, let's use an example. Again, I'll use the one that's in the book in the lecture slides. If I have this number, place value is going to become important. And so we talk about this number as 143. Now this number, we have to read this rightmost decimal as its fraction. So this the first place was 1 to the 10th, or 1/10, not 1 to the 10th, sorry, 100th, 1,000th. And so this decimal is saying that I have 143 as the whole number, and 56 my delete is not going well. I don't want to say 56. I want to write it 56 1,000ths. And we add this th 1,000ths. And so we get these extra place values. And so the decimal point divides fractions and whole numbers. But by keeping these powers of 10, we get all the same rules that we had with whole numbers. And so let's look at how we can name some of these. So let me do a number that has 0 for its whole numbers and 2 decimal places. So again, the first place is the fraction 1/10. Second place is 1/100th. And so this, I have 6 100ths. Or we can say 600ths. Decimals can be signed. So change color here. I can have a negative 124.52. And so we would say that negative, because it has the negative sign, 154 and 52 hundredths. Oops, 52 hundredths. Let's look at another one. We'll make a longer decimal here. So this is the tenths place. This is the hundredths place. This is the thousandths place. And this would be the 10,000ths place. And so we look at the number here and we read it as 829 10,000ths. 829 10,000ths. And so this notation lets us do very specific fractions. And we can also do standard form with this. So if I were to say, whoops, let me, in words, $12 and 600ths. So and is going to be my decimal point, and the 12 will go before it. Now the 600ths means, well, hundredths means I'm going to have 2 decimal places, and 6 is going to be in the second decimal place. So I need 2 decimal places, so I have 6 hundredths. Let's look at another one here, converting the words. We'll convert the words to a standard form decimal. So I could have 54 and 72 thousandths. So the and will be my decimal point, and I have thousandths. So thousandths means I need 3 decimal places, and I'm going to have 72 in them. But I need to fill in the 0 here because it holds place. And then for my whole number part, I have 54. And so that's how that decimal gets created. Now, there are some fractions. We can look at this as fractions, and we can talk about the fractions that come from decimals. So I have a decimal, 0.5. It's 5 tenths. That's how I would say it. As a fraction, it's 5 over 10. And we know from the previous chapter, in simplified form, that's 1/2, because they both have factors of 5. So this is the decimal way of saying 1/2. I could have this decimal, which is 36. Right, I'm going to say the number, 36, and it fills to the hundredth place, so 36 hundredths. So that means 36 over 100. Now, in simplified form, these are both divisible by 4, right? 4 times 9 upstairs here, and 4 times 25 downstairs here. And so if I get rid of these, I get 9 25ths. So decimals relate to fractions. They relate to these fractions where the denominator is this word from how we describe them. They define the place that our far right decimal is in. So this is in the hundredth place. That's going to be what makes the fraction. This number makes the numerator. And then we can move to simplified form. Let's look at a couple more. I look at my places, and that's the tenths, 1 over 10, the hundredths, and the thousandths. So I have 2 thousandths. The place is the denominator, and the number upstairs comes from what we would say the number that we get from there. Again, this can be simplified. Both of these are divisible by 2. So that's 1 over 500 in simplified form. So we can write a decimal, any decimal, as a fraction or mixed number. Let me clear this out. And let's look at another one. So 0.9 has 1 decimal place, and so that's the tenths. So this will have a fractional part of 10. Then in the number itself forms the numerator. And this is already in simplified form. So 0.9 is 9 tenths. Well, if we have this as a decimal, we'll look here. Well, we have a whole number, so I'll write the whole number. And then I'll look at my fraction. That's the tenths place, the hundredths place, the thousandths place. So the denominator is going to be made of the thousandths place. And the numerator is this number, 94. And so we have a mixed number, which we can simplify. This one's going to be hard. I know they're both divisible by 2. In fact, 94 divisible by 2 is 47. And 1,000 divisible by 2 is 500. And I think 47 is as simple as we can get. Now, decimals can be compared, and they compare a lot easier than fractions. Remember, with fractions, we had to write them with the same denominator to really do a good comparison of them. Well, with decimals, if I am going to compare these two decimals, this number fills the bigger space. Just like in our whole numbers, that the larger the number is in the left, the bigger it is. And so I could write these with the same number of decimal places. This has 3 decimal places, so I could make this 3 decimal places. Now there's nothing in the thousandths place, so I put nothing there. And so if I compare these, I have 370 thousandths and 27 thousandths. So this is the bigger number. Of course, we don't write those extra zeros. And so we would compare it like this. But we can always expand the smaller number of place number to try to match the larger number of places. So let's look at a mixed number and do a similar comparison. If we look, 28 and 253 thousandths and 28 and 263 thousandths both have the same number of decimal places. They're both 28. So they're sitting on the number line just past the number 28. This number is smaller than this number here. And so we would compare it like this. And that difference is happening right here in the hundredths place. And this is bigger in the hundredths place. Let's look at another one. I'm going to compare 26 and 208 thousandths to 26 and 28 hundredths. Now this has 3 decimal places. This only has 2. So to compare, I can put a 0 here. Doesn't change the value of this because I'm adding 0 fractional parts, but these have the same fractional parts. So this tells me I have 280 thousandths, and this means I have 208. And so this is the bigger number. Right, but we originally had it written like this, so we'll compare them in its original form. Well, that means we can do things that we did with decimals, that we did with whole numbers. Writing it in this form, writing fractional parts in this form, let us use all of the comparison values that we had in whole numbers. We now have algorithms that will treat fractions just like we treated whole numbers. And so if I have 63 and 782 thousandths, and I want to round this, and you'll sometimes hear it say to 2 decimal places, or the nearest hundredth. You'll hear people round either by the number of decimal places or by what that fractional value is for the second decimal place in this case. So we do the same thing. We mark the number that we're comparing, and we look to the number to the right of our marked number. If it's less than 5, we drop it. If it's more than 5, we drop it and round this up. So let's look at when we did a round down, let's look at rounding up. So I have 326 and 4,386 ten-thousandths. And I want to round this to the nearest hundredth. So round to nearest hundredth. So I'll mark my hundredths place, and I'll look to the value to the right. It's bigger than 5, so I'm going to increase this by 4 and drop everything else. Or increase this by 1, 2, 4. Pardon my bad English there. And that would be round to the nearest hundredth. Well, what if our measuring device wasn't that good and we said round to the nearest tenth? Or 1 decimal place. So I'll rewrite my original number. I'll mark the number I want to round to, and I'll look to the right. It's less than 5, so I'll drop everything to the right of it. And that's this rounded to the nearest tenth. Now this happens with money. Banks do this all the time. We can round to the nearest cent. So if I have some calculation where I'm calculating the percentage of money, well, the smallest unit of money we have is a cent, which is 1/100th of a dollar. And so this would be 1 cent or 1/100th of a dollar. So if I round to the nearest cent, I mark this number and look to the one to the right. It's bigger than 5, so I increase my number and drop everything to the right of it. And so 67 thousandths of a dollar rounds up to 7 cents. And a cent is 7/100th of a dollar. And so this is our introduction to decimals. They're going to be this thing that we use to do fractions where we get all of the algorithms we had with whole numbers. And we will continue to explore this as we work our way through the chapter.